Hello guys, welcome to my YouTube channel MATHSOLOGIA. This is part 2 continued video of a discrete probability distribution. In this video, we are going to discuss another three problems related to discrete probability distribution. Yes, here a fair coin is tossed three times. Let x denote the number of heads showing up. Find the distribution of x. Also find its mean, variance, standard deviation. In the last video, we discussed three problems. In all the three problems, distribution table was given so that we could find easily the value of k, mean, variance, and standard deviation. Here, the problem is in statement form. We have to convert this into probability distribution table form. For that, a random experiment is given here. This is fourth question. Fair coin is tossed three times. Means this is a random experiment. If coin is tossed three times, the sample space we already know what's the meaning of that. The set of all possible outcomes of a random experiment is called sample space. Here, a fair coin is tossed three times. Then there will be totally 8 outcomes. So first time head, second time head, third time head. Like this, first time head, second time head, third time tail. And then head, tail, head. Then head, tail, tail. So starting with head, these are the four possible outcomes. Next, first time tail, second time head, again head. Then tail, tail, head. Next it can be tail, head, tail. Then tail, tail, tail. So if you count, it will be totally 8 outcomes. So total outcomes equals to 8. Is 8. Now for each outcome, we have to assign a random value or real number. To assign the random value, in the question itself they mentioned clearly, x denote number of heads showing up. So that is the random variable defined here. X is equal to number of heads showing up. So this is the function defined, means the rule is we have to follow here for every outcome. For triple H, correct? You have to apply the function, you have to apply the rule for that first outcome. X of HHH, that is 3. Next, X of HHT, we get 2. Just count number of heads in each outcome of the experiment. Next, X of HTH, how many heads are there? 2. Then X of HTT, here we have 1 head. Similarly, you have to find for remaining outcomes X of THH, here we have 2 outcomes. Next, X of TTH, we get 1. X of THT, number of heads 1. X of TTT, number of heads is 0, because in last outcome there are no heads at all, so it is 0. So these are called random values. So x can take here values 0, 1, 2, 3. Here 2 is repeated 3 times, but we should not write 3. 3 times 2, we should add only 2. We already discussed before, range cannot be repeated. The values in the range set should be appeared only one time. So 0, 1, 2, 3. Now, for every random value, we have to find the probability of 0, probability of 1, probability of 2, probability of 3. So we can write here x p of x. Write 0, 1, 2, 3. Now we have to find here probability of 0. Now just check here. We have totally 8 outcomes here. Total we have 8 outcomes. In that, how many times 0 appears? 0 appears only one time. So probability of getting 0 head is 1 divided by 8. We should know first what is the meaning of probability. Probability definition is number of favorable outcomes divided by total number of outcomes. This is the mathematical definition of probability. Favorable outcomes by total number of outcomes. Favorable means what is required to us. Here we need probability of 0. How many times 0 appears in this list, in this outcome? Only one time. Therefore probability is 1 divided by 8. Now probability of 1 means how many times 1 appears here? 1 time, 2 time, 3 times. See. So 3 times it appears, favorable is 3, total is 8. So 3 by 8 we write. Next, probability of 2. 2 appears here 1 time, 2 times, 3 times. So we write here 3 by 8. So probability of getting 3 heads, here only one time it appears. So we write 1 divided by 8. So this is the way how to find probabilities of the defined random values. We can check here whether this table follows the condition or not. Definitely it follows. P of x is greater than or equal to 0. According to the condition, probability values should be always greater than or equal to 0. And if you add all the probabilities, just add here 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8. Total 8 by 8 is equal to 1. It is also satisfied. In the last three problems, what we have discussed, this table was given beforehand. Here, the problem is in statement form. Now, we have converted the statement into problem form with the help of outcomes and with the help of a random variable defined in the question. For this table, we have to find mean and variance according to the question. See, coin is tossed 3 times. Let x denote number of heads showing up. Find the distribution of x. So that a table what we wrote, that is called distribution of x. Also find its mean, variance and standard deviation. First part is over, finding the distribution. Next, mean. So mean is calculated by using the formula mu is equal to summation x into p of x. Just multiply the corresponding random values and probabilities. Add all the numbers 0 plus 3 by 8 plus 6 by 8 plus 3 by 8. So here we get 6 plus 3 9, 9 plus 3 12, 12 divided by 8. 12 divided by 8 means it goes with 4, 4 into 3, 4 into 2. So this is the mean value. Next we need variance. Variance formula v is equal to summation x square p of x minus mean square mu square. Here we have to square x and then multiply the probabilities equals to 0 square into 1 by 8 plus 1 square into 3 by 8 plus 2 square into 3 by 8 plus 3 square into 1 by 8. So I have to multiply squares of x and then into p of x minus mu square. Mu here from the previous step we have 3 by 2 whole square. 3 by 2 whole square. So calculate this, we get 3 by 4. This is the variance. Once we get variance, we can easily find standard deviation. Standard deviation is given by, we know already the formula, equals to square root of v, square root of 3 by 4. This would be 0.866. It continues like this. This is called standard deviation. Next problem. So this is fifth question. We have a random variable x as a density function p of x is equal to kx square, where x takes the values 0, 1, 2, 3. Evaluate k, also find the probabilities. Here p of x is given kx square, where x values are 0, 1, 2, 3. Okay, if you read the table, x and here p of x. P of x is kx square. 0, 1, 2, 3. So p of x, p of 0, you put x is equal to 0 here, you will get 0. You put x is equal to 1 here, you get k into 1 square is k. You put x is equal to 2, 2 square is 4, 4k. Yeah, 3 square 9, 9k. So this is the distribution table. To find k, we have to add all the probabilities and equate to 1. So 0 plus k plus 4k plus 9k is equal to 1. 4 plus 1, 5. 5 plus 9, 14. So 14k is equal to 1, and this gives k is equal to 1 by 14. After this, we have to find the probabilities. P of x less than or equal to 1. It's a very easy question. So P of x less than or equal to 1. P of x less than or equal to 1. Less than or equal to 1 means we have two values, P of 0 plus P of 1. P of 0 means 0, P of 1 is k. 0 plus k is k, and k is 1 by 14. Next, P of 1 less than or equal to x less than or equal to 2. Here endpoints also included. P of 1 plus P of 2 plus P of 3. Yeah, 1 and 2 means 3 is not included. Then just you will get P of 1 and P of 2. So P of 1 means here k. P of 2 is 4k. We get 5k. So 5k gives 5 by 14. Because k is equal to 1 by 14. 5 into 1 by 14 is 5 by 14. Last one, P of x greater than 2. P of x greater than 2. Greater than 2 means we have only one number, P of 3. Don't include 2. So P of 3 is 9k. 9 into 1 by 14 equals to 9 by 14. So this completes the solution of this problem. Here we are not asked to find mean and variance. Just evaluate the k after finding distribution table and then find the probabilities. This is another statement problem. We have to convert this statement problem to probability distribution table form. And from there we have to find mean and standard deviation. This is completely different from the previous questions. Your box contains 12 items, of which 4 are defectives. A sample of 3 items is selected from the box. Let X denote the number of defective items in the sample. X means random variable, we should remember. Find the probability distribution of X. Determine the mean and standard deviation. First, just copy the data from the question. X means what? Number of defective items. Here, box contains 12 items. Okay, box contains 12 items total. Out of 12 items, defectives we have. Defectives given what? 4. If defectives are 4 means, what about non-defectives? In total, you have to subtract defectives will be 8. So we have 4 defectives, 8 non-defectives. If we add both, we get total items in the box, that is 12. Out of 12 items, 4 are defectives. That is understood. Non-defectives will be 8. And understand this question carefully here. A sample of 3 items is selected from the box. Sample of 3 items selected from the box. Without seeing, randomly you have to select. This can be done in how many ways? This can be done in out of 12, 3 are selected at random. So we can do it in 12C3 ways. This is called sample space. Means total number of outcomes. Total number of ways we can say. 12C3. Here C stands for combination. This value can be obtained from calculator. In calculator, there is one option NCR. N means 12 here, R is 12. In calculator, you have to type in this way 12C3. It gives directly one value. Sample space is 12C3. Now we have to assign the random values. Here they mention clearly X is equal to number of defective items. And 3 items is selected from the box. Then X can take the values here 0, 1, 2, 3. When you select randomly 3 items from the box, there we have 4 options. When you select 3 items, 0 can be defective, no defectives at all. Second option, out of 3 items, 1 can be defective. Out of 3, 2 can be defective. Out of 3, all 3 can be defective. So these are all the possible values of the random variable. So X can take here 0, 1, 2, 3. Now for each random value, now we have to assign the probability. From there we get the probability distribution table. So to be more clear here, if you write one box, it will be clearly understood. So here we have defectives. Here we have non-defectives. Okay. So total we have 12 items. In that, defectives are 4, non-defectives are 8. So possible chances are first 0. If you pick 0 defective items, non-defective will be 3 out of 3. If defective is 1, non-defective will be 2. If defective is 2, non-defective is 1. If defective is 3, defective is 0. Because we're selecting here 3 items from the box. First time if you select 3 items from the box, you can see 0 defectives. 0 defectives means what? There should be 3 non-defectives. That is one case. This is case 1. We can say case 1. In case 2, out of 3 items, 1 will be defective. If 1 is defective means other 2 should be non-defective. In third case, C3, out of 3, if 2 are defective, 1 should be non-defective. In case 4, if 3 are defective, 0 must be non-defective. So these are the 4 different cases we have to follow. Now one by one we shall see probability of x is equal to 0. This probability of getting 0 defectives. 0 defectives means what? We have totally 4 defectives. Out of 4, we can select 4C0 into non-defectives will be 3. First case, I'm reading for first case. Out of 8, 3 non-defectives can be selected in 8C3 ways, divided by total outcomes are 12C3. Sample space. This is the favorable outcome and this is the total outcome. That is the definition of probability. Number of favorable outcomes by total number of outcomes. So in calculator you can easily find the values here. This gives 14 by 55. Next option. Second case we have here probability of x is equal to 1 means getting one defective. One defective. Case 2 we have one defective. One defective selected from 4. We get 4C1 into 2 from 8, 8C2 divided by 12C3. This option answer will be 28 by 55. Next, case 3. Probability of x equals to 2. Defective items. You are selecting 2 defectives out of 4 means it will be 4C2 into. In third case, 1 non-defective is there. It will be 8C1 divided by total outcome 12C3. Answer will be here 1 by 55. Sorry, 12 by 55. You can verify this in calculators. And then probability of x is equal to 3. Last case. Here 4C3 into 8C0 divided by 12C3. Here we get 1 by 55. For all the random values, we have assigned the probabilities from 4 different cases. So write this in the form of table that gives probability distribution table. Here x, here p of x. Random values are 0, 1, 2, 3. For 0 we got 14 by 55. For 1 we got 28 by 55. For 2, 12 by 55. For 3, 1 by 55. This is distribution table. So using this table, we have to find the mean and variance. So mean, again same formula, mu is equal to summation x into p of x. Just 0 into probability 0, 1 into 28 by 55 plus 2 into 12 by 55 plus 3 into 1 by 55. This gives the answer 1. Next, variance. Variance V is equal to summation x square p of x minus mu square, mean square. Square the elements. 0 square into probability is 0 only, and 1 square into 28 by 55 plus 2 square into 12 by 55 plus 3 square into 1 by 55, close the brackets, minus mu square is 1 square. So the answer would be here 6 by 11. If there's standard deviation, just take square root of V, square root of 6 by 11. So this is the answer. So that's all about all the problems under discrete probability distributions. Thank you.